So though we had finished most of the parts of cis and trans isomerism in the last class itself, but a small part was still left, and that was E and Z nomenclature. I had given you a slight idea of E and Z in the live class itself. So let's quickly see some rules on which we can figure out E and Z isomers of alkenes. Now, where do we use this E and Z isomerism? We use it where generally there are 4 different groups are present on the carbon double bond carbon. So where cis and trans cannot work, we preferably use E and Z isomerism. Now, E and Z isomerism is based on set of priority rules. Basically, we need to understand what all different rules will decide which particular molecule is E and which particular molecule is Z. And when I say priority rules, means when you talk about the functional groups present on one carbon, you set a priority. You tell which group is priority, higher priority group, and which group is a lower priority group. So basically, if you have a molecule A, B, C and D, this is carbon 1, this is carbon 2. So carbon 1 has 2 groups A and B. So we'll compare A and B's priority. We will find out which one is higher priority, which one is lower priority. Assume that we have A as a higher priority group and this is a lower priority group, B as a lower priority group. Similarly, we'll go to C2 and we figured out that C is a higher priority group and D is a lower priority group. So basically what we can see over here is both of the higher priority groups are on the same side and both of the lower priority groups are on the same side. So this basically the groups are not same, but the priority is same, and hence when they are on the same side, they are basically behaving similar to how we call it as a cis. These are not cis. You cannot replace the term cis over here. We have specific terms for it. So when 2 higher priority groups are with each other or basically in the same plane, we call them Z isomer. And if they would be opposite to each other, higher, assume this would be higher and this is lower. In this case, the isomer would be E. So there are 2 terms. If the higher priority groups are on the same side, it is called a Z isomer, and Z means zusammen, that means together in German. Okay. Similarly, if they are in the opposite side, it will be called as E isomer. E isomer means entgegen, and that means opposite. Again, it is in German. So basically, both Z and E are the terms or the words have been taken from the German language. Okay, so this is the basic understanding about what is Z and what is E. Now, how to decide the group is higher priority or lower priority? For that, we have to follow some certain rules. So now let's understand the rules to figure out which particular group is going to be a higher priority group. Now, let's say I have taken an example over here, carbon double bond carbon, and I have on the first carbon chlorine and iodine attached, on the second carbon bromine and fluorine attached. Okay, so now here, on first carbon there are 2 groups, iodine and chlorine. We will look at the atomic number of the element which is directly attached to the carbon. So with the carbon, iodine is directly attached and chlorine is directly attached. If I look at the atomic number, iodine's atomic number is going to be more, and hence it has the higher priority. Similarly, when you talk about carbon 2, it has 2 groups, bromine and fluorine. Bromine has higher atomic number and hence it has higher priority. So if you look at this molecule, 2 higher priority groups are opposite to each other, and hence this isomer is going to be E isomer. Now, what would have been its a Z isomer when both the higher priority groups would be together? So basically, if Br and iodine would be on one side and fluorine would be on the other side, this will be your Z isomer. So this is one way. Okay. Now the question here is, it's not necessary that we would have only atoms present on the attached on the carbons. It can be the molecules also over here. In that case, how would we decide? Let's figure out. So in case of groups also, we also look at the direct attachment. For example, if I have carbon double bond carbon, I have OH, I have NO2, I have CH3, and I have hydrogen. So let's say I have these 4 groups present over here. So I'll see the direct attachment of carbon with the immediate atom. So carbon here is directly attached to the nitrogen, here directly attached to the oxygen, here directly attached to the carbon, and here hydrogen. So if I compare the direct attachment, so direct attachment is carbon and hydrogen. So which has higher atomic number? Carbon has the higher atomic number. So this is priority 1 or higher priority. Similarly, if I talk about here, in this case, oxygen, nitrogen are the direct attachments. So oxygen has higher atomic number. So this is priority 1 or the higher priority group. So this, if both of the higher priority groups are on the same side, so this will be Z. If these would be in the opposite direction, then in that case it will be E. Now here the confusion comes if I have something like this: CH3, CO2. Let's not write CO2. Let's write COH or C2H5 or CH3. So now in this case, what is happening? The direct attachment of the carbon is with the attachment of the carbon is with the carbon only. So we cannot decide on the basis of immediate attachment. So what we will do in that case, we will go to the next attachment. So what do I mean? This carbon is next attached to hydrogen. Okay. This carbon, the CH3, see, all the immediate attachments are carbon. So we cannot compare on the basis of this. So what we'll do, we'll look at the next attachment. So my carbon is next attached to hydrogen. So point of attachment of comparison is hydrogen over here. Here, the direct attachment is with the oxygen. So basically the group is like that, C double bond O, OH. So I have taken oxygen, any of the oxygen I can take. So next point of difference is oxygen over here. Point of difference here is hydrogen, and point of difference here is, here C2H5 can be written as CH3CH2, and this CH2 is attached to the carbon. So this carbon was first point of difference, but it is same in all the cases, so we are not referring to it. Now here we have three options. We can take hydrogen as the next atom, or we can take carbon as the next atom. In these cases, in such cases, we will always prefer taking carbon, or the one which has next highest atomic number. So carbon will be taken as, because it will be written as this, right? So next point of attachment we will be referring it to is carbon. You got my point, what I'm trying to say? So first carbon we could not consider, because everywhere the direct point of attachment was carbon only. So next immediate attachment is again carbon. So here point of difference is carbon. So compare between carbon and hydrogen. Carbon has the higher priority. So this is your priority 1 group or higher priority group. Here between hydrogen and oxygen, which has the higher priority? The one with the oxygen. So this is higher priority group. So higher priority groups are opposite to each other, and hence this will be called as E. So same rule I have written it over here. The relative priority of two groups, if cannot be compared due to the direct attachment of the atom is same, in that case we will go to the next atom or next sequence of atoms, and then we will decide which has the higher atomic number, and accordingly we will give priority 1 or priority 2, or higher priority or lower priority. So similar example I have taken over here. Here it is direct comparison, CH3 and hydrogen. CH3 is going to be higher priority. Okay, I have already mentioned it over here, by the way. Okay, and when you compare it over here, CH2, CH3 and CH3, here with the carbon next attachment is hydrogen, here with the carbon next attachment is carbon. So this is going to be higher priority. So both higher priority groups are on the same plane, hence this is Z. Okay, so that's how you will be deciding if the immediate attachment is coming same. Now next, the last rule is, if just in case we have a group attached on the carbon which has double bond or triple bond, how to treat it, how to behave with it, or how to figure out which is the higher priority and which one is the lower priority. So in that case, first of all, we resolve this triple bond or double bond. And how do we resolve? We basically treat each bond as an individual bond. That means if carbon has formed a triple bond with nitrogen, here we will basically hypothetically imagine that carbon is individually attached to 3 nitrogens, and these 3 nitrogens are individually attached to 3 carbons. That's how it will be. So it will look like, so we have to basically resolve it like this. So carbon is directly attached to 3 different nitrogens, and these nitrogens are further attached to 3 carbons, 2 here and 1 with this carbon, 2 here and 1 with this carbon, 2 here and 1 with this carbon. So when you will resolve it like this, then only you will go for next setting the priority of any group. So how to use this rule? I'll just give you an idea. Let me just rub it off, and then I'll explain you with the help of example. Okay, so this is the example which I have taken. Now let's try to understand the same rule using this example. Now in this case, if I compare this and this group, what all I have, carbon and carbon is the direct attachment, so we cannot compare it using that. This carbon has the next immediate attachment as only hydrogen, so we have no other option but to take hydrogen as a reference. Here we have 2 hydrogens and 1 oxygen, and then further hydrogen. So basically it is like this. And OH, and this is the point of attachment. So as I mentioned earlier also, that we will look out for the next immediate higher atomic number element. So higher atomic number element here is oxygen, so point of difference is going to be oxygen. So when we compare these two, this is going to be a higher priority group. So this is resolved. Okay, now let's compare these two. So what we have here is, again, the immediate point of attachment is same, CH and carbon and carbon. So we cannot compare it using the carbon. So we have to figure out the next attachment. So let's see. It has 2 hydrogens and 1 carbon as the next attachment, right? Look at the next one, the down group. Now, as I mentioned, that we have to resolve the double bond, and we have to resolve it in such a way that we will treat both the bonds as individual bonds attached to the carbon. So I can take it as it is attached to CH2, and this is attached to CH2, and your CH2 is further attached to a carbon. This is CH2 is also further attached to a carbon. Now you don't have to do much messing with this, and there is a bond with which it is attached to the carbon, double bond carbon here. Okay, so that's how we have to basically resolve. So what we can see here is, just understand, after carbon the immediate next element is further carbon here, right? So next immediate element is carbon. Here also the next immediate element is carbon, right? So we cannot compare with the next element also, because again the next element are same. So next, go to the next attachment. So next attachment is hydrogen over here, and here is again carbon. So here we have 2 carbons, whereas we have only 1 carbon attachment over here, and hence we are comparing carbon with hydrogen now. So carbon is the point of difference in hydrogen, and hence this group is going to be higher priority. I'm not sure whether you have understood or not, but let me just try to explain you again. Basically, we were comparing carbon and hydrogen. Basically, the next point of attachment was carbon over here, and next point of attachment was carbon over here. So it was same. Go to the next group. So next point of attachment was hydrogen, and here we have carbon as well as hydrogen. But I told you what you have to look for. You have to look for the higher atomic number one, or higher atomic mass one. Okay, so the element which has the higher atomic number will be looked after late in the second step. So here again we have carbon. So we are comparing carbon and hydrogen now. The third point of attachment would again be hydrogen, but we wouldn't even reach till here, because the second attachment itself is giving you the difference, and that will decide what is higher priority group. Now let me just take one more example. So basically here 2 higher priority groups are on the same side. So this is Z. Let me take one more example. I have taken the example 2. Now in this case we have to compare between chlorine, bromine. Bromine is higher priority. Okay, now when we'll compare these two, carbon is the immediate attachment, so we cannot compare it using it. Let's resolve this molecule. It will be carbon with 2 hydrogens and 1 NH2, and then that's how it is attached. Look at this, carbon triple bond nitrogen. As I mentioned, we will treat each bond as an individual bond with nitrogen, and nitrogen is further attached to 3 carbons. That's how it is. So now let's compare. Now when the carbon is same in both the cases, then I'll move to the next immediate higher atomic mass thing, and that is nitrogen. So nitrogen is also same in the next category, right? So we will go to the third attachment. Third attachment is hydrogen over here. But what is the third attachment over here? Nitrogen. Even if I go to the fourth attachment, hydrogen over here, what is here? Nitrogen. So this has higher atomic number, hence this is higher priority group. So that's how you have to resolve. Simple. These are the mainly set of rules which we'll be following while solving the question for E and Z. Now there is one more important thing which I would like to tell you, and that is, just in case if you have 2 or more than 2 double bonds, how to write the configuration. So let's say if we have So this is my molecule. I have written it in a nice manner, but it could be written in a simple straight chain, and then you had to basically calculate E and Z individually. So in this case, what you'll do, basically you'll find out E and Z separately for each double bond. Okay. So for example, if you talk about this is higher priority and this is lower priority. Both the higher priorities are opposite to each other. So this is E. And what about this? This is higher priority and this is higher priority. They are also together. So this is Z. Okay. So now if I'll number the chain, I'll start numbering from here. 1, 2, 3, 4, and 5, and 6. That's how it will be numbered. Correct? I mean, if I have to name the molecule. So when you name the molecule, you will write. Now, what you can see over here is on the first carbon, 1Z, comma. Next double bond is on the fourth carbon. So 4E. And then you will write the name of the whole molecule. Okay, basically first double bond is Z and fourth double bond is E. Then comes your name of the molecule. That's how you will represent E and Z. If one would be E, other would be Z, in that case, let's say, assume it would have been like this. H here and CH3 here, then it would be E. So we would have mentioned 1Z, 4Z, and then the name of the compound. Okay, so that's how we mention E and Z for 2 or more than 2 double bonds in the carbon chain. So this is all about your E and Z. Try solving few more questions from the books what you have, and if you have any doubt, you ask me and I'll explain you. Okay, so this is the end of your geometrical isomerism. Next we'll be starting optical.